Hi everybody, this is the second part of lecture number 4. It's going to be substantially shorter than the first part. So when we're talking about research in psychology and research in general, we want to talk about validity. And there's 4 big types of validity. There's what's called internal and external validity, which we've already talked about. We'll review those briefly again. And then there's construct validity and there's statistical validity. Internal and external validity, we've talked about this before. Basically, internal validity is that if you're doing an experiment, is there experimental control? The only thing that's varying is your IV, and that's related very much, obviously, to cause and effect inferences. And then there's external validity, does it relate to the real world? And so these types of validity have a sort of a counterbalance to each other. So typically when you have more internal validity, you have less external and vice versa. But we talked about experiments in the real world that can balance both of those. So I won't go into a lot of the stuff that we talked about before, but basically from an experimental perspective, and so this lecture is about experimental design. So how do experimentalists address the lack of external validity? So they're typically very high in internal validity, but how about external validity? And so there's this argument about what's called mundane realism. Basically, is it like everyday life? Do people take it seriously? So I'll give you an example. The Ash experiment, which you watched earlier, you might watch that and say, this is kind of stupid. I wouldn't care whether I got the line right or wrong, and I probably wouldn't conform because it's just about stupid lines. It's nothing big. But what I'll say is that this experiment has been replicated much more recently, and in context where people think they're relatively anti-conformist. And I've watched the videos of these more present-day versions of that experiment, and you can see how much stress people are under. So that Ash experiment, even though you think it's nothing, it's about stupid lines, doesn't really have to do with anything. In the experiment, the people are under a lot of stress. They feel a lot of being torn. They know that the people are giving the wrong answer, but they just don't want to go against the grain. I would argue that Ash experiment has mundane realism. So although it seems like a simple little situation, people take it very seriously. And therefore, I'd say it has that mundane realism because it's like everyday life. And so, if you have an experiment that has mundane realism, then it helps you make those generalizations, because external validity has to do with a lot with generalizing your findings. Can you generalize it to the real world? Can you generalize from your experiment to the real world? Can you generalize it from your sample to people in general? And those experiments that have mundane realism, I'd say yes, it does have that generalizability. There's also this argument about psychological realism. So is there essentially the same mental processes going on in the experiments versus the real world? And I'd say that's probably true. So that experiment, the Ash experiment, for example, those processes of conformity, the emotions, the thought patterns of the person who's being pressured to conform, that's probably very similar to real-world situations where people are pressured to conform. So I would argue that Ash experiment, as an example, has psychological realism. The things that we're seeing in terms of conformity, what's producing the conformity, what the person's feeling, who's being sort of pressured to conform, I would say that would be very similar to what people experience in the real world. So the Ash experiment also has that psychological realism. And we talked about field experiments. You can watch this video. This video gives you a lot of examples of field experiments. I don't know if every study cited in this video is a field experiment, but a fair number of them are. So do watch this for some examples of field experiments. So the second, I should say the third, because we did external and internal validity together. The third type of validity is construct validity. It's a very broad term. Basically, for our purposes, we often will use that for questionnaires. So for questionnaires, we are basically asking, does the questionnaire capture the construct completely and accurately? And if you remember from one of our first two lecture videos, can't remember which one, but when we're talking about variables and defining our variables, I talked about that we want to define the variable as completely as possible, thinking about the different ways it can manifest because of this very reason. The better your definition, the more complete your definition, the more manifestations of that behavior that you list in your definition of your variable. If you can measure those things, then that will better assure construct validity. For experiments, it's a little bit different. For experiments, it usually has to do with the experimental manipulations. So the manipulation of your levels of the IV. So a big thing here is, again, operationalization. If I can say it, I have a speech impediment. Operationalization. And so operationalizing your variable is one of the things that we sort of did with the definition of the variable in lecture number 2, I think it was. So by defining the complete aspects of the variable, we were operationalizing it. For experiments, it's often in terms of how can we operationalize a variable in a way that the IV levels will capture that. So I'll use an example that we've already talked about. We've been talking about the narcissism stuff. And in the lab exercise number 2, I gave an example of maybe translating ego threat into an independent variable for narcissist, because narcissists will be more aggressive under conditions of ego threat versus under conditions of not being threatened in terms of their ego. So the aggression would show more in the cases of ego threat. So ego threat, well, what do we mean by that? How can we operationalize it? So in terms of an IV, that false feedback condition, where we say, for half the people, we say you're in the bottom 10%. That's pretty threatening to an ego, right? So that's an operationalization of ego threat. And we can think about operationalizing the variable also in terms of things we watch. So Darley and Latine, they're curious about diffusion of responsibility. So they operationalized it in terms of having 0 peers in the study, 2 peers, and I think it was 5 peers or 4 peers, something like that. So that's operationalizing how many people is around you to bring to life that concept of diffusion of responsibility. And then for Ash, it's conformity. So conformity was simply in terms of the number of people saying the wrong answer, the Confederates. And operationalizing dissent. So 0 dissenters versus 1 dissenter. So these are just operationalizing the independent variables of, for one, Darley and Latine was diffusion of responsibility. For Ash, it was conformity, number of people, and the effect of having a dissenter. So construct validity often is about those experimental manipulations and whether they make sense conceptually in terms of the actual variable that you're trying to see have an effect on people. And when you're in terms of construct validity, the big issue in terms of operationalizing an independent variable is what are the actual conditions and what's the number of conditions. So we often think about things like what's called thresholds. So what will kick something in? So, for example, for thresholds for the Darley and Latney, if you had conditions of one versus two people, that's probably not good. You probably want 0 peers because you want to make sure that there's, in conditions where there's not diffusion of responsibility, there's nobody else there that you're going to actually do something, you're going to help somebody. And then 2, there's a step up in diffusion of responsibility, and then 5. So you want to choose steps that will have thresholds that you can see differences in behavior. So again, just having like 1 versus 2 people is not good because you want to have that 0. You need to have that 0 comparison, and then having this gradient between 1 and 2 might not be so sensitive. So having difference between 0 and 2, difference between 2 and 5. And some of this in terms of thresholds and sensitivity is just thinking conceptually and thinking in terms of common sense. And you also want to convey the nature of the variable. So the nature of the variable of diffusion of responsibility is captured better by the 0, 2, 5. Again, if we lack the 0, we don't know what will happen if there's no diffusion of responsibility. And also, we want to see if this gradient from 2 to 5 produces any differences in people. And I would say this is probably one of the biggest keys to designing an experiment is to have these sensitive thresholds in your level of your independent variable. So if you notice, I was trying to think a little bit about the alcohol thing. So the beer goggles one, I was trying to think, what's the threshold? Again, we wanted 0, so we wanted no alcohol in a form of placebo, hopefully. And I was thinking then 2 drinks and 4 drinks. I know it's a little bit messy, but you want to think a little bit about some gradients. You don't want to compare probably 1 drink to 2 drinks because there's that much alcohol difference between 1 drink and 2 drinks. So you need to think about those gradients and what sort of gradient in the independent variable will produce changes in the dependent variable. So what gradient in alcohol is going to produce differences in attraction? And by the way, I sort of forgot that. I forgot to debrief you about the beer goggles experiment. So beer goggles, this has been looked at in various studies, both in terms of naturalistic studies done in bars and lab studies. And so what I'll say is that the scientific evidence is pretty clear that beer goggles don't exist, at least in terms of alcohol affecting your attraction. Beer goggles might exist as excuses. So beer goggles are a great excuse if you did something maybe not so smart, and you can just blame the alcohol. But what I'm telling you is science says it's just an excuse, it's not reality. So lab studies and real-world studies has demonstrated that alcohol has no effect on attraction ratings. What has an effect, though, is there is a certain type of goggles, I guess. It's called time goggles. And so when it gets closer to closing time of a bar, people get a little bit more desperate. People start looking a little bit better to them. So there is something that's affecting your attraction ratings, and it tends to be time. And this is true for bars or for parties and things like that. So basically naturalist, and this is the thing, experiments can't answer every question. So in this case, experiments could answer the question of does alcohol have an effect, and it doesn't. But what's going on? Why do people come up with these excuses? And there seems to be a time effect. And so people might be a little bit more drunk at the end of the night, perhaps, and they think, oh, it's the drinking that made me do it. No, it's you were desperate because the bar was closing or the party's ending. So that's what's going on with that question of beer goggles. And the last type of validity we'll talk about here, and we'll address validity later in the semester too, because that's an important concept. There is something called statistical validity. That just basically says you're doing the appropriate statistics. So if you remember from your stats classes, each of those statistics are done under certain conditions. So independent t-test, paired t-test, one-way ANOVA, repeated measures ANOVA, correlations, regression, chi-squares. Each of these statistics are done under certain situations, and it basically has to do with the level of measurements of the variables, or levels of measurement of the variables, and also the design, whether it's between subject or within subject. So based on the levels of measurement and the research design, you should choose the appropriate statistic. The bad thing is, if you choose the wrong statistic, SPSS will still run it. SPSS is not smart. It will do whatever you tell it to do, even if it's wrong. And so doing the appropriate statistic is important, because doing the appropriate statistic will actually test your hypothesis. If you do the inappropriate statistic, one of two things, or both. You can't make a proper conclusion about your hypothesis, or the findings are so messy that you actually can't understand it because you've done something inappropriately and the data don't make sense. So statistical validity is very important, because if we don't do the appropriate statistic, we can't make the proper conclusion about our hypothesis. Also for statistics, not just appropriate statistic, but also do our data meet the assumptions of that statistic. So if you remember, each statistic has various assumptions. A lot of it has to do with things like normality, homogeneity of variance, things like the something being distributed normally. So those are three typical assumptions of parametric statistics. And so even if we chose the appropriate statistic, if our data don't meet the assumptions of that statistic, then the conclusions are invalid. The numbers are invalid. So basically, statistical validity has to do with making proper conclusions from the data from the statistical test. And just sort of a note, you can have relatively small sample sizes. So sample sizes of 20 to 50 are not unusual in psychology, and those are fine. For one, the P levels take care of that. So if you have smaller samples, you need a larger statistic value for it to be significant. So if you remember that from stats class. So if you have smaller sample sizes, you need a larger statistic to say there's something going on to reject the HO. Also from statistics, you should remember the central limit theorem. So central limit theorem also sort of takes care of that, is that the central limit theorem, if you take a bunch of samples of the same size from the same population, if you plot the sampling distribution from those things, it tends to be normal. So basically, when we take samples, we know that the samples are not going to perfectly represent the population, but we know that the whole world of sampling distributions will tend to be normal. So that's how we make our conclusions of our inferential statistics test. And so we can make pretty solid generalizations, inferences from relatively small samples to a relatively large population. Sometimes people do what's called power analysis. So in power analysis, what they do is they look at previous research on the topic, and they get a sense from the previous research about the effect size that has generally been found in that research. And what they do is they project that effect size, and then they can calculate a sample that they need to get it to be significant. So if I know what the effect size is, I can find out what sample will find this to be significant. So you actually start backwards, and then you take your sample, you make it big enough according to your power analysis. I'm not a big fan of that, because that sounds like you're kind of tweaking things, that you're trying to do the bare minimum and get enough subjects to be able to say it's significant. To me, that sounds a little bit weird. And this is a good reason why we do effect sizes. So In your statistics class, I hope that you learn the difference between null hypothesis statistical testing, which is the p-value stuff, the inferential statistics, versus effect size. So in research in psychology, we've moved from just reporting the null hypothesis statistical testing, which is the p-values. So was your statistic significant or not, to having that plus effect sizes. Because we know people can play games and increase their sample size to find something to be significant, but the actual magnitude of that effect could be relatively small. So we are going to report in this class both our p-levels, our null hypothesis statistical test part, and we're also going to report our effect size. So how big is the effect? In terms of practical advice for experiments, so practical advice is that you want to standardize the procedure. Of course, you want to standardize it because we want to make sure that there's no extraneous variables. Nothing's varying except for the independent variable. And a big way of doing that is to standardize your procedure. In terms of expectancy effects, oftentimes people want to use what's called double blind. So blind refers to not knowing the level of the IV. And definitely in terms of the participant should not know what level they're in. Also, in terms of double blind, you don't want the experimenter to know. So the person who's running the subject, running the experiment with the person, they also should not know the level that the person's in. And also, hopefully you hope that the experimenter does not know the hypothesis of the study, although that's oftentimes violated. So if we have double blind, in addition to the participant not knowing what the levels are, the person running the study doesn't know. And in this way, they can't convey any sort of expectations about how the person should behave. Of course, you want to have a written protocol. We don't have to do this for this class, but for the future, you should know these things. You should have a written protocol. Even if you're the only experimenter, you should have a written protocol because you don't want to just kind of wing it and you do it different this day than another day. You want to have a standard procedure that's written out. Definitely if you have more than one experimenter, this gets to be really important because then you might actually have some sort of confound where somebody's running some group of subjects more than another person, and there's actually a systematic variation between who's running the studies in terms of the different levels, and then you might get differences in the levels because of the people running the different levels rather than the actual IV level. So if you have any instructions for the participants, they should be written out. And sometimes you do it orally because sometimes people don't want to read. But if you have it written, it helps standardize it. You should anticipate questions. You can't anticipate every question, but you should anticipate questions that participants might have and then give standard answers to your experimenters. You want them to practice doing it beforehand. So before actual people come in, you want them to practice. I think what I've done in the past is I've had my experimenters, or I don't have experiments, but my researchers practice on each other. So the interviews, the attachment interviews that we did, for example, I had people practice it with each other or with people who aren't in the lab, and these things were not recorded. But it was just practicing because I didn't want somebody to sit down for the first time, never having given the interview, and just do it with a participant. That would not be smart. So you want people to practice beforehand. I mentioned this earlier, is that there's a possible confound if you have somebody running one level and another person running another level of your variable. That would be bad. That could create a confound. So you want to make sure that there's an even spread across conditions. So if you have three experimenters, they do 1/3 of condition 1, and each of them do 1/3 of condition 2. So you make sure they're all equally spread out. You want to make sure you keep records. So again, we're not doing this for this class, but this is something you should learn in this class. Typically, we would do a study where you run participants. So you should keep some records. So for each person that comes into your experiment or your study, you want to list who the experimenter was, because if something screws up, you want to be able to go up and find that person and say, well, what happened, or what do you remember about this? You probably want to put the time and the date of when you're doing the experiment or the study. Demographics of the participant without revealing their identity. So you might want to get their age and their gender identity, something like that. But this would not be connected to their data, by the way. This would just be kind of keeping track of who came in and what data are connected with them, even though it won't go into the data set. And if anything weird happens, so for example, if you have a confused participant who doesn't seem to catch on what they're supposed to be doing, or maybe they're uncooperative. So you want to make notes about that, because you want to follow up and you want to see if their data is kind of weird. If they're confused or they're uncooperative, maybe you might want to throw out their data. Maybe the data are not valid. And you might want to have an ID number. Probably if it's like a one-shot thing, you probably don't want that. But let's say, for example, our study on romantic attachment, we had them do several things. So first, they filled out a questionnaire online before they came in for the study. So they filled out a questionnaire online. Then they came into the lab and they did two things. One thing they did is they did the interview. So the interview about their romantic relationships, they did that. And then after the interview, we asked them to sort those cards about their personality. So we had 100 cards of personality traits, and we asked them to sort it in terms of what things were more like them and what things were not like them. So description of their personality, essentially. And then about a week after the lab part of the study, we had them fill out another questionnaire online. So essentially, we had 4 pieces. So we had questionnaires before, we had the interview, which was coded later with the recordings, and then we had the in-person recording of the personality sorts, and then we had a questionnaire that they did about a week or so after they were in the lab. So we had all these pieces, and so what we did is we had an ID number. And so everything they did, they had an ID number, and that ID number was able to help connect all those parts of the data within a data set for the person. So we could relate all these things together. And why we used an ID number is that way it's not identifiable. So I was the only one that knew the match of the ID number and the person. And then those things were destroyed once we integrated and connected the data pieces. But I kept it in a secure spot, and it wasn't with the data. It wasn't even stored in a lab. It was stored in my own secure places. And so that way we were able to protect the participants, and this made it anonymous. What you don't want to do is you don't want to say things like, Mark Sanchez. So here's Mark Sanchez, and he did the questionnaire. Here's Mark Sanchez's questionnaire. Oh, here's Mark Sanchez's interview. Here's Mark Sanchez's questionnaire, or the sort of their personality. Here's Mark Sanchez's follow-up questionnaire. And it all has Mark's name on it. And, you don't want to do that. Because if somebody somehow gets your data, they know about Mark Sanchez's personal life. And we don't want that. We'll give a code, an ID number. Nobody knows who that person is except for me. Also, in terms of experiments, in terms of practical advice, oftentimes people want to do what's called a manipulation check. And so what a manipulation check basically is doing is it's saying that, okay, yes, in terms of construct validity, you try to think of an independent variable that's going to match some sort of construct. So the ego threat. So the ego threat, I think it's ego threat if I tell them that they did horribly, that they did worse than 90% of the people that did the thing. So I think conceptually it means ego threat, but what a manipulation check does is it actually has a separate measure of that IV construct to see if it actually is working. So, a classic example of this, let's say that you make an idea that stress somehow affects some sort of outcome. And your operationalization of stress was making somebody prepare for a speech in 5 minutes. So you say that you're going to do this speech in front of a class that's down the hall. The class has about 40 people in it. You have 5 minutes to prepare a speech on this topic. Good luck, and I'll see you in 5 minutes. So you think that induces stress in the person. But you might say, well, maybe not. Maybe people, I don't know, maybe people might not see that as stressful. So what you do is you can do several things. You can have a questionnaire measuring stress. So maybe before they're supposed to give this speech, you have them fill out a questionnaire and there's some stress questions. So you can get a measure of it. Or what's probably better is having something like blood pressure readings. So take their blood pressure before the experiment, and then when you stress them out, take it again to see if their blood pressure has changed. And if their blood pressure goes up, then you can say, oh, I stressed the person out. An example of a manipulation check is from my own undergraduate studies. So I took this class, obviously, when I was an undergraduate, and we had to do our own studies, so in person. And our independent variable was humor. And we were curious whether humor made somebody more creative. And so what we did is we had, basically this IV of humor, and we had a comedy tape that we had that people listened to for, I think, 5 or 10 minutes. And then the other level was somebody listening to some sort of boring lecture that we found online or something. So the person either heard the funny tape of the comedy or they listened to the boring thing. And I remember my professor at that time said, well, you don't know if people will find this comedy tape to be funny, so you need to check this. And so probably one of the more uncomfortable things I had to do in my life was, I shouldn't say that, I should say in terms of doing research, we had to watch people listening to the comedy tape to see if they laughed. That's what the professor said. The professor says, do a manipulation check, and you can say that it was a funny tape, it was humorous to people if you saw them laugh at least once. And so we had people listening to this tape in a room that had a one-way mirror. If you don't know what a one-way mirror is, you might see it in cop shows. For example, is that, on one side where the person is, it looks like a mirror, and then on the other side, somebody can stand there and watch the person. I don't know if the technology is different for police stations, but those cop shows are, I think, inaccurate in the sense that you can't have light on where you're watching the person because they can see you then. So the trick with one-way mirrors typically is that you have to be in a dark room watching them, because if it's dark, they can't see you, but if it's light, then all of a sudden they can see you. Me and my partner, we had to take turns doing this, and I hated it because unfortunately the observation room was actually a storage closet. It was actually quite small. And so it wasn't very comfortable being there in the first place. And then the only place we could have people listen to the thing and actually see that if they laughed was really up against that mirror. There was like kind of like a desk or a table area that was wedged onto that mirror. And so really the person was literally less than 5 feet from us, even though they couldn't see us. And so had to sit there and stare at people. You might think, oh, people probably know that you were watching them. No, they didn't. They were picking their boogers and doing all sorts of weird things, which made me quite uncomfortable. And so that was our manipulation check. And just sort of to end that little story, and why, for sure, I know that the lights can't be on, and I knew that. I was in that storage closet, and somebody didn't know we were running the experiment. I think we had a sign up, like, don't come in here. Somebody came in and put the lights on, and I had to dive onto the floor because I didn't want the person seeing that I'm sitting there staring at them. And so I kind of was not happy with that person who came in and turned the lights on. So that's an example of a manipulation check. And that's an example that even though you think people act weird and experiment, sometimes they act natural and they pick their boogers. Another sort of practical thing is when you do experiments, you want to pilot test. And you want to do this in general. You want to pilot test your questionnaires and things like that, but pretty much any design you want to pilot test it. Even observational learning. So observational learning you might have, or observational learning, observational research. You want to have an observational checklist or a way of collecting data from the observations, but you want to pilot that to make sure that your observers can actually use that and get usable data, so you pilot it. So piloting is you basically just try it out before actually doing the study. So typically with pilot tests, you usually ask for, if it's a naturalistic observation, you can just go watch people, no problem. But if it's like a lab or questionnaires, you usually ask your friends or family or somebody you know to test it out. So when you do a pilot test for an experiment, you have maybe your friend come in and you run it on them just as, not to collect data, but just to see how things go, whether they understand everything. So in terms of your instructions, you might want to ask your friend, were you able to understand what you were supposed to do? How can it be clear? You might see any mistakes they make. So you think that you've given them proper instructions, but they do something wrong. And you're like, oh, no, now everything's all ruined. So you want to make sure if there's any misunderstandings, mistakes. This also will help you anticipate questions that will be asked. So I talked about anticipating questions and having standard answers. So those questions, well, in your pilot, you can make sure that the person you're piloting asks questions if they have any. Pilot tests are great to see if they become bored or frustrated. So you think it's a great study, it's a great design, but it ends up being a very tedious thing or it's a frustrating thing. You don't want that to happen. Pilot testing, you time how long it takes. Typically, we tell people when you come into the study, it's going to take you 20 minutes, approximately 20 minutes to do this. We want to be truthful with them and we want to give them credit for that. So if we do it and it ends up being 90 minutes, we might want to think, oh boy, either give them more compensation or maybe I need to shorten this somehow. This is too long. You might want to run the pilot and see if your friend can guess what the research question is or the hypothesis. That's an important thing. Can the participants see what you're doing? Of course, if they can see what the question is, then you can think about, well, how can I make this a little bit more subtle? This is, of course, great to test equipment. So if you're using things like computers or other things, make sure everything works properly before you actually start running people. And then you can check in terms of, are the data recorded accurately? So whether it's a machine, so if there's a machine recording data, make sure that's done. Or if you ask your experimenter to record the data, are they able to accurately record the data in a way that makes sure that it's all valid, no mistakes? Because sometimes people have troubles with sort of interacting with somebody and then recording the data. So for example, with my romantic interview, so one part's easy because we recorded the interview, but then the personality sort was a little bit more troubling because basically it takes some time to sort these 100 cards out. And so what I basically told my experimenters was just leave the cards on the table. Don't make the person sit around until you record everything because I think that's unfair to them. So I said, when they're done, debrief them, get them out of there. Don't touch the cards. And I had to train them, don't put the cards back because some people might think, oh, I'm all done. No, you're not done. You have to write down the numbers of the cards that are on the table. So you want to make sure that people understand that. So you want to do pilot tests so they don't just sort of see the cards and they think they should put it back in the deck. Like playing cards, no, you have to write stuff down beforehand. So you want to make sure that all of this stuff is done in the proper way. Your experimenters understand it, and they can record the data accurately. And that's it. So this second part was not as long as the first part. So That's it for this lecture, and I'll talk to you in the next lecture.